relation between these two. Next slide, please. The relationship between the two. All right, so to explain this part, I'll be given the definition of artificial intelligence. And artificial intelligence is just a branch of computer science that uses machines and programs to simulate intelligent human behavior. So we have machine learning, the subset of AI, is a subset of artificial intelligence that allows the goals of artificial intelligence to be accomplished. It allows the goals of AI to be achieved. Okay, and presently the term artificial intelligence is a bit too ambiguous since there is no such thing as complete autonomous artificial intelligence or so. So presently at the moment, what we have is for a programmed algorithm to work, then this algorithm needs to be fed with data. This algorithm needs to be fed with quantities of data in order to learn, train, and make predictions. All right, I think we've been able to get that. So let's go on to the next slide. Let's see about the next one. So how does machine learning work? The next slide, please. All right, so how does machine learning work? Okay, so here is the concept. In machine learning, an algorithm needs to be fed with data, as I've said earlier. It needs to be fed with data, and it needs to use computer programming languages. Algorithms are being processed with computer programming languages in order to train, learn, and make predictions. All right. So an example in Excel will be to classify skin lesions as either malignant or benign skin cancer, or benign skin lesions, sorry. So in this kind of example, first we start with this example. Then the first thing is data. This algorithm needs to be fed with quantities of data, and then the data we'll be using in this case will be images of skin lesions. Data will be images of skin lesions containing either benign or malignant skin lesions. Yeah, I hope you get that. So this machine learning model, we get to learn from this data. And the kind of algorithm, there are different types of algorithms a programmer can use, and then it depends on the kind of problem this programmer needs to solve. It depends on the kind of problem this programmer needs to be solved. The kind of problem that needs to be solved. All right. So after being fed with the quantities of data, the algorithm needs to be told whether these images are containing benign or malignant skin cancer, which is going to serve as the target variable. It's going to serve as what we are making a crucial prediction on. Okay, so this machine learning algorithm will now start from a place of little knowledge. If we start learning from a place of little knowledge and become knowledgeable, if we get to understand better through the process of the data fed into it. And then there are different types of algorithms. Hello?
I'm hearing you.
Okay, all right. So there are different types of algorithms, and then the one chosen by the programmer. Hello? Okay, let me just go forward. The one chosen by the programmer will depend on the kind of problem that needs to be accomplished. All right. So in this case, if we want to classify skin lesions as either malignant or benign skin cancer, then we are going to use a classification algorithm. It will be a classifier, which will be able to explain that enough. So let's go on to the next slide. Let's go on to the next slide, please. Okay, this is the third question we are having here. If a machine learning algorithm is always correct? I should even allow us, because I know there are still some people that are very conversant with this area. If a machine learning algorithm, the kind of predictions the algorithm is making, if they are truly correct, I should allow us to debate on this. But okay, here is my answer concerning that. Okay, the thing is, the effectiveness and the correctness of an algorithm will solely depend on the quantity, on the quality of the computer code from which it has been written from, the kind of computer code written by the programmer, and also the quantity and quality of data from which this algorithm is learning from. So depending on this, my answer right now is no. A machine learning algorithm is not always correct because there are some things we really need to put into consideration, ranging from the quality of data and whether the algorithm solely fits the problem it is tackling. I hope we get that. So this programmer just needs to find the best model, to choose the best model for the problem, for the real world problem the programmer is trying to solve. All right, so let's go to the next slide. Yeah, this is the real deal for today. Here we'll be talking about the various applications of machine learning in healthcare, how much machine learning has impacted the healthcare sector, the healthcare field. All right, I've been able to divide this into 3 categories, ranging from diagnostic, treatment, and then innovation. Yeah, under diagnostics, machine learning has really helped in medical field. It has helped in identifying diseases and diagnosis. We'll also be talking about the application of machine learning in predicting epidemic outbreaks. Also under treatment, we have personalized treatment, precision medicine, cancer treatment, which is the most known presently. Cancer treatment, also robotic assisted surgery. And then under innovation, we'll be talking about the application of machine learning in drug discovery and manufacturing, the application of machine learning in clinical trial and research, how machine learning has impacted the process of crowdsourced data collection, like we getting data from the web, collecting data from the web. And the last one, we'll be talking about the application of machine learning in maintaining healthcare records. All right, so let's pick them one after the other. I would like to explain this into a tiny bit we'll be able to understand better. All right, let's go to the next slide. Okay, this is medical imaging. We'll be talking about the application of machine learning in medical imaging. And as we all know, a machine learning algorithm can process unimaginable amount of information in the blink of an eye. And even it will be more precise than human in detecting the smallest changes in medical imaging. And then the path-breaking advancement we are having presently is the Google machine learning algorithm. It's the Google machine learning algorithm, which is capable of, which is capable of identifying cancerous tumors in mammograms. Also, we have a company called Zebra Medical Vision, and this company were able to develop a platform called Profound. And then this Profound platform is capable of analyzing all types of medical imaging. And then this Profound platform can detect every sign of potential conditions, like breast cancer, different types of cancer, or osteoporosis. And this accuracy will be very, very high, depending on how the algorithm has been trained. So this project is being able to provide up to 90% accuracy rate. All right, so let's go to the next one. Let's talk about the next one. Here is the application of machine learning in identifying diseases and diagnosis. Okay, as we all know, machine learning algorithms are being used in detecting diseases and in detecting diseases. They are being used in detecting diseases like maybe cancer, leukemia with high accuracy. And according to American Cancer Society, as displayed on the slide, so they made a report about how a high proportion of mammograms are yielding false results. And then this is leading to one in elderly women being told they have cancer without them having it. And then we can know the cost of that, what that thing is going to cost. Okay, so the use of machine learning is enabling review and translation of mammograms 30 times faster. We get that. It's enabling the review and translation of mammograms 30 times faster with up to 99% accuracy. And then these are help in reducing the need for unnecessary biopsies. Also, we have this other one, Google DeepMind Health. They are working in partnership with clinicians and researchers. Also, patients in solving and detecting real-world healthcare problems. They are diving deeper into solving real-world problems everyone is facing. All right, so let's go on to the next slide. Let's talk about the next one. Okay, here is the third one, which is showing the application of machine learning in predicting epidemic outbreaks. How machine learning has helped in predicting epidemic outbreaks. All right, we all know that the healthcare organizations, they are making use of machine learning and AI systems in predicting the epidemic outbreak that is going to take over the world. And then they are doing this using, they are being able to do this by collecting data from the satellite, by getting real life updates from the web, and also getting data from people, from users everywhere. And also, I'll be mentioning something here, support vector machine and neural network. Though I should have showed this in former slides, I should have showed the various types of machine learning algorithms we have, but I decided to skip that simply because I don't want this session to be too technical. I want to break this down into something everybody can digest easily. So I'll just be talking about support vector machine briefly and neural networks, just because they are being used in predicting the outbreak of malaria. They are used in predicting malaria outbreaks by considering just small factors like temperature and average monthly rainfall. Also, we have another path-breaking advancement, which is the researchers at University of Nottingham. These researchers, they were able to build a software, though I have to research on this, they were able to build a software that scans patient data, and then it will be able to predict if a patient would be having heart attack in the next 10 years, if a patient is likely to have an attack within 10 years. And then we can know how this is going to really help the world. All right, so let's go on to the next slide. Let's talk about the next one. Okay, this is the application of machine learning in drug discovery and manufacturing. Okay, so machine learning has been able to find its way into different sectors, into different places, and then this drug discovery section is not left behind. Machine learning has found its way into drug discovery, especially in the preliminary stage, and it is being used by pharmaceutical companies. And at present, this is still limited to unsupervised machine learning. Oh, okay, I skipped that one too. There are different types of machine learning algorithms, but we don't really need that for this section. So what we really need to grasp is that an unsupervised machine learning is being used in identifying patterns in raw data. So manufacturers are making use of machine learning, and they can use this thing to reduce the overall time required to develop drugs. So this has helped in reducing the cost of manufacturing. All right, so let's go to the next slide. Let's talk about the next one. Okay, this is personalized treatment. We'll be talking about how machine learning has impacted personalized treatment. And then we know that artificial intelligence systems, they've been created to analyze data. They analyze data, visualize data, make predictions. They'll be able to note and report from patient files, even more than what clinical expertise are capable of doing. And then it will help in selecting the correct and individually customized treatment path for each patient. And then, so now, instead of estimating the risk to the patient based on his or her systematic history, instead of the doctors passing through this number of stress, the doctors can rely on the predictive ability of machine learning to diagnose their patient. They can rely on the machine learning totally to diagnose their patient. All right, so let's go on to the next slide. Let's talk about the next one. This is clinical trial and research. As we all know, even though we must not have taken part in research before, but we must have heard about it that making research always takes longer time. It requires time, effort, money. And sometimes this process is going to stretch for more than a year. It will stretch more than a year, 2 years, and a lot. Okay, so machine learning, the intervention of machine learning can help in bringing down the time and money investment in clinical trials, can help in bringing down the time and money investment in research, in making research. And it will also deliver accurate results more than what humans are capable of doing. All right, so let's go on to the next slide. Let's talk about the next one. Okay, we have crowdsourced data collection. As we all know, different platforms like Google, Chrome under Google, they always make use of user data. And then the healthcare sector is not left behind because they are extremely invested in crowdsourcing medical data from multiple sources. They always crowdsource data from mobile apps, at times healthcare platforms. And then, though, of course, with the concept of people, they'll always get the concept of people. Like you would always get a pop-up on your browser, whether to allow cookies or not. We all must be familiar with that. Okay, based on this pool of life data, based on these tons of data the healthcare sector are having, the doctors can deliver speedy and necessary treatment to patients. The clinicians can deliver speedy treatment to patients, and there won't be no time wasted. There won't be any time wasted in fulfilling paperwork. There won't be any time wasted in queuing, staying on the queue at the hospital, and so on. All right, so recently, the Apple Research Kit grants, the Apple Research Kit, they've been able to grant users, they've been able to grant them access to interactive apps. And then these apps are making use of facial recognition systems to treat Asperger's and Parkinson's disease. We must know how much this has impacted the world, when a facial recognition system is capable of treating Asperger's and Parkinson's disease. All right, so let's go on to the next slide. Let's talk about the next one. Okay, we have the application of machine learning in maintaining healthcare records. We all know, pertaining to the number of patients we always have in the hospital, pertaining to the number of people that always come to the hospital to register, those that are injured, and a lot more. And then keeping the record for each of the patients has been a very huge task, and this has been taking up a lot of time. Maintaining up-to-date health records is very, very exhausting and time-consuming. If you have some those working in the department at those healthcare sectors, you would know what they are facing. All right, so machine learning records is an area where machine learning has entered. And so machine learning has entered this area in saving time, effort, and money. And then there is another path-breaking advancement, which is Google Cloud Vision API and MATLAB machine. This machine learning-based handwritten recognition are being used for document classification methods. They are being used in documenting healthcare files. They are being used in documenting and classifying each of the records. All right, so having spoken about that, let's go on to the next one. I think this is the last slide we have in concerning the various applications of ML in healthcare, and this is robotic assisted surgery. Oh, this is the biggest advancement, making use of robots in surgery. Robots assisting healthcare workers in police. They've been used in medicine for more than use of robots. They can aid human surgeons, and they can also operate. They can also perform operations by themselves. They can take up tasks by themselves, just that they are being used for time-consuming tasks, for repetitive tasks, for tasks that are very strenuous for humans. So robots are being used in this aspect, also in rehabilitation, for those in the area of occupational therapy or physical therapy. The application of robots is being enhanced in these areas. Robots are being used in physical therapy and then supporting patients with long-term conditions. Yeah, this is how much robots have been assisting the healthcare sector, which is an application of machine learning. All right, I haven't spoken about the various applications of machine learning in healthcare. Then we're moving forward into the limitless opportunities for ML in healthcare. All right, next slide. Okay, I'm very sure we can all see the slide. So I've been able to make this picture ranging from the various ways ML opportunities have been announced in the healthcare sector. So machine learning has helped in reducing readmission. It has helped in reducing hospital-acquired infections. Also, hospital length of stay. It has impacted the prediction of chronic diseases and also reducing 1-year mortality. Also predicting patient no-show. It can help in predicting patients that are likely to show up. All right, so let's take this one after the other. Let's take them one after the other. So this is reduced readmission. Yeah, in order to explain this concept, and then I will try and talk about the main problems the healthcare sector is facing. And then this is the problem of minimum standard of shortfall of doctors. Since, as we all know, up to like just 50,000 of doctors are being produced every year. Just pertaining to talking about Nigeria, let me say, 50%, 50,000 doctors are being produced every year to take care of more than 1.3 billion people, to take responsibility for more than 1.3 billion people. So this is an area where machine learning has been applied, where it has helped in reducing readmission. And in this area, the clinicians or doctors, they can get guidance as to the number of patients they will be receiving per day, as to the number of patients they will be getting at the hospital. And then it can help doctors in focusing on this number of patients and then taking care of them fully, taking care of them as expected. So machine learning has contributed in this area. Also, preventing hospital-acquired infections. Okay, so machine learning has helped in preventing hospital-acquired infections. And this is mainly done by predicting high-risk patients, by predicting patients that are having high risk to a particular infection. So by predicting such patients will be taken care of faster so that this kind of infection won't spread throughout the organization, throughout the hospital. So machine learning has really helped in this area. Also, hospital length of stay. Machine learning has impacted this area too in reducing hospital length of stay, in reducing how long a patient is going to stay in the hospital. And then it has also helped in patient satisfaction. Yes, patients get satisfied by how much machine learning has impacted doctors in providing the best solution, in providing in how they are being catered for. All right. So let's talk about how machine learning has helped in predicting chronic infections, chronic diseases. I would love to talk about this class C. It's called central line. What's the full name? It's a disease, sorry. Class C. And then as recorded, 40% of patients having class C, 40% of patients having this are likely to die. 40% of patients having class C, they are likely to die. Also, machine learning has impacted this area by detecting patients with decentralized infection. And then after detecting such patients, they can be catered for separately from the rest of the patients. And then it can predict how much this infection is going to affect the patient. Also, let's talk about reduced 1 year mortality. MS has helped in reducing patients' 1 year mortality. It can help add one more year to a patient's lifespan. All right, predict no show. Yeah, machine learning has contributed in this area in predicting patients that are likely to show up, patients that are likely to come to the hospital in a particular day. All right, so let's go to the next slide. Yeah, we talked about ethics around machine learning in healthcare. We all know there will surely be ethics. Yeah, ethics. So let's go to the next slide. Okay, having seen this is showing ethics around ML in healthcare, and then I've been able to divide this into two, ranging from healthcare workers displacement and also biases in predictions. Yeah, let me talk about the first one, healthcare workers displacement. And then to explain this, many people are afraid about the fact that machine learning and AI systems, they are going to displace healthcare workers. That machine learning systems and solutions, robots and machines, they are going to displace doctors and clinicians from their workstation. And then, though we all know machine learning is disruptive, but many people are casting this destruction into a negative light, and then they are projecting a future where robots take away human jobs, take away jobs from human workers. And this is just one way to look at it. If you want to look at it broadly, machine learning is not going to take away jobs from humans, but rather the medical job is going to change. How doctors are going to be, how recruitment is going to be taking place is most likely to change. So machine learning is going to change the medical job rather than displace healthcare workers. All right, let's talk about the next one, biases in prediction. So thinking about biases in prediction, we all know, having talked about it earlier, that is a machine learning algorithm is always correct, but this solely depends on what the programmer is doing. Okay, to explain this, let's talk about a facial recognition system, for example. Let's talk about when a facial recognition system is being trained with images of non-Nigerians, with images of non-Africans. If a machine learning algorithm is being trained with images of the white people, then we are now expecting this algorithm to make predictions on it, to recognize a face of a Nigerian. Then we should know that is not possible. But this particular case, the medical researchers, they've been able to recognize this, and then they are presently working on it. And care must be taken during the development of AI systems to ensure that data from a range of racial and ethnic backgrounds, that data from gender identities are being included while these models are being trained. They must be included with diverse data sets so that it can generate the whole races and everything you have it. All right, so these are things that can be taken care of. The healthcare workers displacement, you can just try and change with the revolutionizing word, just try and change with the revolutionizing AI, and then you'll be fine. And also the biases in prediction, medical researchers are working on it. Even programmers are taking note of this as well. Okay, so let's go on to the next slide. Let's go to the next one. This is where I'll be talking about beginners, those that want to venture into machine learning in healthcare. I know, having been inspired since morning, a lot of us will be like, oh, I want to venture into ML in healthcare. I want to learn more about machine learning. So I've been able to divide this into two. If you want to learn computer coding first, This is talking about pure beginners if you don't have any understanding of computer coding. And then the next one, if you're having the technical knowledge already, or you just want to venture into ML in SQL, just want to dive deeper, just want to make amazing innovations, then these are the steps you have to follow. If you want to learn computer coding first, then there's this programming language you have to learn, which is Python programming. Yeah, it's just the fundamental. It's the basic programming language. So after learning Python programming, though this slide is not covering everything, but I'll be explaining this by mouth. So after learning after learning Python programming, then you would have to learn data analysis and visualization, which are parts of data science. And we all know data science is a subset of machine learning, while machine learning is a subset of artificial intelligence. Oh, sorry, I don't want us to be confused. Okay, so you have to learn data analysis and visualization also in order to analyze data and generate insights from medical data. So after learning this, then you dive into machine learning fully. So for you to take a machine learning course, I'm recommending this one on Coursera by Andrew Ng. It's a very nice course. It's a very powerful course, and I can testify to it. I also took the course. Okay, so you have to learn machine learning, take a course by Andrew Ng on machine learning on Coursera. So after learning this, then the journey goes on and on. So if you are, let me talk about those that are now having the technical knowledge, those that know about machine learning already, and then you want to venture into AI for medical diagnosis, then I will be recommending this course. I will recommend this course on Coursera as well. So sorry, I'm a fan of Coursera. Okay, you can go for this course on Coursera as well, AI for medical diagnosis by Pranath Rajpoka. It's a very nice course for anybody who wants to venture into ML next year. Right, I think we've been able to digest this. So let's go on to the next slide. Let's talk about the next one. Yeah, this is where I'll be talking about how we're moving from theoretical to clinical reality. Okay, this is a project I was able to work on. I collaborated with a team of software developers, even though they are Tanzanians and not Nigerians. I happen to be the only Nigerian among them. And then we were able to work on this particular project. I worked as a machine learning engineer for this, and then we were able to build a model that is capable of predicting cancer. It is capable of predicting cancerous tumors in microscopic imaging. So I would want us to watch this 3-minute clip. It's just 3 minutes. So bear with me. We're going to learn a lot. So let's be focused and let's learn from this video. All right. All right. So having watched this, I know a lot of us, many of us must be inspired right now. I know we all must be inspired right now. We all want to do amazing stuff like though this is just very simple as it's just a documentation of the project. But I know we all must be inspired right now, and we also would like to, even if I know a lot of us here, we are medical students concerning during the introduction section, we are most of us are medical students, but we can all venture into ML next year in order to build amazing stuff. Those making amazing stuff, we can't consider them as those working at Google or those working at Microsoft. They are not the only one that can build stuff, amazing stuff. They are not the only one that can change the world. They are not the only one that can take part in building amazing software. So this starts from you and I. This starts from every one of us on this call. So I know through the inspiration, I hope we can all make path-breaking advancements of the world at large. All right, so let's go on to the last slide for today's session. Let's go on to the last one. Oh, I must have taken a lot of time. So sorry, everyone. Okay, so if you want to reach me in case you have a question or you want us to collaborate on something or you just want to say hi, just for any reason, you can message me on Twitter. I'm on Twitter as Precious. Also, I'm available on LinkedIn as Kolawole Precious. I'm available on LinkedIn, and then you can message me via email. I will reply in a few. Okay, so you can get to reach me, we can get to collaborate, we can get to talk and build amazing stuff together. So I hope I've been able to impact few of us here on this call, if not everyone. I hope I've been able to impact, I've been able to at least embed something in us. All right, so thank you for having me on this call. It's a very big privilege. It's a very nice privilege. Thank you very much, and I hope you enjoy the rest of your day. All right, thank you. So I've been handing over to One HealthTech now.
All right, thank you, Ms. Precious, for such a wonderful and amazing presentation. Okay, we'll be taking questions now. Anyone with any questions, please raise your hands and you'll be called on to ask your questions. You can also type them in the chat if you don't want to talk. No questions? Okay, Miss Precious, we have a question from Olaoluwa in the chat section. Can you hear me?
Yes, I can hear you.
Okay, he asks, what's the timeline and steps to being a data scientist slash ML engineer? The timeline.
Okay, so this is it. I think I explained that earlier. If you want to become a data scientist, if you want to be a machine learning engineer without any knowledge, any background knowledge in tech, then you have to start from Python programming. There are many courses online you can take concerning Python programming. Then I would recommend that of Udacity. I always recommend that for people. So after being comfortable with data or with Python programming, then you would have to learn data analysis and data science. There are different courses. This is something you can learn online. I learned everything from online courses and Stack Overflow, everything you get. So you get to learn data analysis. And after data analysis, you learn data visualization. There are different softwares for visualizing data. We have Power BI, we have Tableau, we have Plotlight. So you have to learn those softwares, those tools, you have to make use of them. And there's SQL, structured query language, for querying data from databases. All these things I'm saying, they are under data analysis visualization, which are subset of data science. So on learning the visualization tools, Power BI, Tableau, and Plotlight, and also learning how to query data from database, which is SQL, then you can now venture into machine learning. You can take a course on introduction to machine learning. That of Udacity is a very nice course. Udacity is a platform for taking online courses, and most of their courses are free. So you can just sign in with your Google account and just get started with the course. So you can get the intro to machine learning course, then you'll get to know how to build machine learning models. Then as time goes on, I would always recommend a project-based learning. As you are learning those stuff online, make sure you are building projects on them. If you get to learn visualization, then look for a project in visualization, maybe a data set you can work on that you can visualize. Then you can get to know that. When you venture into machine learning, take a project. There are different data sets you can get, even medical data sets on Kaggle. Kaggle is a platform for hosting hackathons, competitions, online competitions for data scientists and machine learning engineers. So if you get to Kaggle, you can get different courses, different data sets, sorry. So you can just play with this data set, get to build real life projects by taking courses and following the path. So after being able to build machine learning models, that is when you can venture into end-to-end machine learning. There's something called end-to-end machine learning. You getting to know how to deal with real-world problems. Most data scientists, they always have their projects on their laptops. They always have their projects on their local machines. So you must venture into end-to-end machine learning. This is you deploying machine learning models online, on the web, aside from having them on your local machine. These predictions your algorithms are making, you have to make them live. You have to get it out there for people to know you've done something. So after being able to learn end-to-end machine learning, deploying your data set on the web and everything, there is this aspect of AI. It's also under ML in healthcare though, and it's called deep learning. Once you are comfortable with all those ones I've mentioned, then you can dive into machine learning, into deep learning, sorry. Deep learning is just like computer vision. Computer vision. Like the short clip I put just now is a computer vision project. So you can get to do deep learning, which is computer vision, natural language processing, GANs. We should know GANs. So these are just pathways in becoming a proficient machine learning engineer. But for now, you can call yourself a good machine learning engineer by knowing end-to-end machine learning, from data collection to data analysis to data visualization, also modeling. After modeling, then hosting your applications on the web, making your project live for people to see. Okay, have I been able to answer your question with this?
Yes, yes, it says yes. Okay, Ebunlua has a question. Please unmute yourself and ask your question, Ebun.
Okay, good morning, and thank you for your presentation. My question is, in the initial part of the when you started the lecture, you told us, after speaking about machine learning and its application in artificial intelligence, you also talked about the deficiencies that have occurred in setting these algorithms or imputing these algorithms in machine learning. I don't know if I structured that right. These have these deficiencies been looked into? Because I feel if you have these deficiencies, then I don't know, there will be a lot of setbacks as regards machine learning. So please, can you expatiate on that?
Okay.
Thank
All
you.
right. Thank you for your question. Okay, I mean, to explain this is where I'll be talking about how the accuracies of machine learning models are being measured. You know, I think I talked about biases in predictions and then how much a machine learning algorithm can be correct, how accurate it can be. So these problems, they have been tackled. These problems, they have been taken care of. Since there are different ways of estimating how well your model, how well your machine learning algorithm is performing, you can get to estimate this. We have something called accuracy. We have another one called precision. We have recall, and a lot more. I don't want to bombard us with technical stuff. Okay, so these stuff are being used. They are being used in knowing how well your model is performing. Most organizations, if you work for them, and then if you have to build the machine learning models for them, they'll be like, your algorithm, the algorithm needs to get to this percentage, this accuracy, this specific accuracy. They will tell you, and then machine learning during the time you'll be taking the course, you would get to learn how the algorithm can be estimated, how the accuracy rate can be estimated. So on getting this accuracy, this correct accuracy the organization needs, then that is when you can shoot your models to them, unless they will not collect it. And concerning the biases in prediction, these medical researchers, they've been able to handle this. They've been able to talk about this. And then there are even live conferences where the main topic is how to tackle biases in predictions. And many programmers are putting this into consideration. They are even, if I want to engage in a project, if I want to build something for now, while training my model, while building it, I would have to like look for those things in the process of building the model, like my data set. If my data set is very diverse, if the facial recognition system I mentioned, if the data set is well diverse for the kind of problem I want to solve. And after that, putting all these things into consideration, also there are ways of tuning your model to perform the best results. There are ways of tuning it. If you get to enter the course, if you get to learn the course, then everything will become clearer. Everything will become clearer, and then it will become more understandable. All right, have I been able to answer the question? Hello?
Yes, 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 you have. Okay, one more thing concerning the timeline and steps to being a data scientist. Like how long, in your opinion, does it take?
Okay, I will use myself for example. Well, I started coding. I delved into programming 2020, January 2020. And even that time, I wasn't having a laptop. I wasn't having anything. But the determination was there. I just wanted to learn this thing because I knew where I was going. I had this focus. Yes. So I started January 2021, and from January, though the learning part is wild, it took a lot of time, a lot of dedication, and a consistency. And the difference between this year and January is just a year. So what I'm saying, I've been able to learn. I've been able to learn machine learning. I'm also proficient in deep learning, also web development, real life, hosting deep real life projects online. I do engage in sorts like building the REST API, backend APIs, and all. And I've been able to learn this in a year. When I started my stuff, I wasn't having any understanding of coding, of what coding really is. And I was even inspired by a brother of mine. Though during data science, we should know, I don't know if we are familiar with Data Science Nigeria. So it was during Data Science Nigeria Bootcamp 2019. My brother attended the bootcamp. That was when he told me about data science. He was telling me how I could bridge the gap between artificial intelligence and health, between data science and health. And the thing caught my interest. So I had the determination, and then I've been able to do that in a year, even though I still have a very long way to go. I'm not yet proficient, I'm not yet okay, I'm not yet where I'm supposed to be, but I've been able to get to this stage in a year. So this is just how long it can take. If you are consistent, then you can get this done in a year as well.
Okay, thank you very much. Are there any more questions? None? Okay, if there are no more questions, then this is the end of this meeting. Thank you so much, Precious Kolawole, for such an amazing presentation. Really learned a lot. Thank you. Okay, everyone, please do not forget to follow us on Twitter at One HealthTech, at OHT _Ibadan. Thank you very much for this. We can leave now.